Okay, you've already watched the videos on how to draw the Lewis structures, so now we're going to start working on the worksheet together. And so the first page has water, which is already done for you, and then hydrofluoric acid, HF, oxygen, and then carbon monoxide. Let's work our way through water, even though it's drawn for you. The first thing you have to do is add up the valence electrons, okay? Water has 2 hydrogens and 1 oxygen. Because hydrogen's in group 1, it has 1 valence electron. And because oxygen is in group 16, it has 6 valence electrons. That gives us a total of 8 electrons to use. The second step is to sketch the molecule. And when we look at this formula, H2O, since there's only one O, it would make sense that we would put the O in the center. And then sketching the molecule, we have to draw the 2 hydrogens on the O. So draw the 2 hydrogens on the O and pause the video to do that. When you start the video back, some of you might have drawn the 2 hydrogens like that. Some of you might have drawn them more at a right angle. Some of you might have drawn them like this. It doesn't matter. All of these are correct. However you chose to draw the hydrogens, any of those would be correct sketches of the molecule. Okay? So, I'm going to draw mine like so. The next step says that we put leftover electrons on the atoms bonded to the central electron, or we satisfy the octets, satisfy the octets of, in this example, it would be satisfy the octets of the hydrogens. Hydrogen never has an octet. Hydrogens can only have one bond. That's a very important rule. Hydrogen can only have one bond. And hydrogen never has an octet. So that means you'll never have any dots on a hydrogen, okay? Never electrons. So we don't do anything. When it says satisfy the octets of all atoms bonded to the central atom, there's nothing to be done here. The next step says place leftover electrons on the central atom. Well, how many electrons have we used so far? We've used 2 there and 2 there. We've used a total of 4. If we had 8 to work with, that means we have 4 electrons left over. So we have to put those 4 electrons on the central atom. You are always going to pair those up. So that's how you would put the 4 electrons on the central atom. You would never, no matter how your sketch is, you would not draw them like this for the 4. You would not draw them like that, all scattered around. You always pair them together. That might be a little close, but like so. So they're always paired up. Okay? The next thing we have to do is you always have to go in and check your structure. Okay, so this is what we have drawn. Did we use 8 electrons? Yes, we did. 2, 4, 6, 8. Does every atom have an octet? Well, in this case, hydrogen never has an octet. But does the oxygen have an octet? Yes, it does. 2, 4, 6, 8. So those are the 2 checks. Did we use the correct number of electrons and check the octets? And so that's the Lewis structure for water. Now I want you to pause the video and I want you to do the Lewis structures for the next 3 on that page, which are HF, oxygen, and carbon monoxide. And then when you start the video, I'm going to work through those and you're going to check your answer. When you start the video back, if we start with HF, the first thing we do is add up the electrons. 8 electrons. Hydrogen has 1 valence, fluorine has 7. The next thing we do is sketch the molecule, and this is our sketch. The next thing we do is satisfy the octets of all atoms bonded to the central atom. Can hydrogen have an octet? Hydrogen can't have an octet. What about fluorine? How many electrons does fluorine need in order to have an octet? It needs 6, and you have to pair those up. Then the next step says put leftover electrons on the central atom. I don't have any leftover electrons because I've already used 8. 2, 4, 6, 8. So I have to do my 2 checks. Does fluorine have an octet? Yes, it does. Hydrogen doesn't. It only has 1 bond, and I've used 8 electrons. So that is the Lewis structure for HF. Moving on, checking what you did for oxygen. Each O has 6 valence electrons, but there's 2 O's, so we have 12 electrons to use. When you start the sketch, when you start the rules, follow the rules in order. Don't try to jump ahead to step 3. This is the first thing we do, is we sketch the molecule. The next step says make both oxygens have 8. Satisfy their octets. That means now that one has an octet, and now this one has an octet. Is that the correct structure? There's 2 things to check. Did you use 12 electrons? 2, 4, 6, 8, 10, 12, 14. You did not. We used too many. So, how can I fix that? Well, you could erase some electrons. So I'm just going to erase those over there. Now I've used 12. If you count them, there's 12. But what's the problem? Does this oxygen have an octet? It does not. That oxygen only has 6. This oxygen has an octet. But the rule is everything has to have an octet except hydrogen, and you have to use 12 electrons. So how do you fix it? That's where you go to step 5. Step 5 says try multiple bonds. So I'm going to add another bond here. And when I add the bond here, I have to remove some of the electrons on this oxygen, because see, those electrons have moved to make that double bond. It does not matter which ones you remove. I'm going to remove the ones here. It doesn't matter if they're on the top or the bottom. Now we go through the checks. Are 12 electrons used? 2, 4, 6, 8, 10, 12. So that checks out. The other check, does each oxygen have an octet? 2, 4, 6, 8. That oxygen has an octet. 2, 4, 6, 8. That oxygen has an octet. So that is the Lewis structure for oxygen. Always go back and do your checks. Moving on to carbon monoxide, we have 10 electrons to use. Start with your sketch. If we start here, and then when we make the carbon have 8 electrons and the oxygen have 8 electrons, what's the problem with that structure? We only had 10 to use. How many have we used? 2, 4, 6, 8, 10, 12, 14. We've used 14. Again, can you just go in, just erase 2 pairs of them? Now we've used 10. So this part checks out. Does carbon have an octet? Carbon only has 6. What about oxygen? It only has 6. So that's not correct. We can only use 10 electrons, and both have to have an octet. So the next thing we do is we add another bond here. Now carbon has an octet. Do you see the octet? Oxygen has an octet. So the octets are fine. What about this number? 2, 4, 6, 8, 10, 12. We've used too many. So what would you do? You can't just erase some because the octets are fine. So why don't we try another bond? If we add another bond, we have to erase some dots. Now first, check this out. Are 10 electrons used? 2, 4, 6, 8, 10. We've used 10 electrons. Do both carbon and oxygen have an octet? Carbon has an octet. Oxygen has an octet. So, that is the Lewis structure for carbon monoxide. Okay? Now, we're going to work on completing that first box of your worksheet. A part on that box says draw the best Lewis structure and show resonance. I'm not worried about the resonance right now. I just wanted to do the Lewis structures. So we've done that. B part says, in the structure above, indicate polar bonds with dipole arrows. This is a dipole arrow. It has a plus on one side and then it's an arrow. You will draw an arrow parallel to each bond. And the arrow will always point toward the more electronegative atom. Electronegativity was a trend that we went over in chapters 6 and 7 in the trends. Do you remember the trend for electronegativity? It increases bottom to top and it increases left to right across the periodic table. Okay, increases bottom to top and increases left to right. What's the most electronegative atom? Fluorine. Because remember the noble gases won't bond? So let's first look at drawing a dipole arrow, and I'm going to go back. They're drawn on water for you. But guys, do you see that when you draw them parallel to the bond, you've got to draw an arrow here parallel to this bond, and you have to draw one here parallel to the other bond. And it doesn't matter if you draw them underneath. It doesn't matter. Okay? Where are you going to point it? You're going to point the arrow towards the oxygen because oxygen is more electronegative than hydrogen. You can tell from its position on the periodic table. Okay, so if we go and we draw a dipole arrow on HF, think about it before I show it to you. It would just have one dipole arrow. Okay, now let's move to oxygen. Parallel to the bond is going to be here, but guys, you've got an oxygen and an oxygen. This is a case where electrons are equally shared. It's the same atom. There's no difference in electronegativity, therefore there's no dipole arrow to draw. What would you do on carbon monoxide? Obviously you're going to draw it here. Where's it going to point? It's going to point towards the oxygen because oxygen is more electronegative than carbon. Okay, now, the next thing I want to do is talk about the formal charge. Okay, that takes care of B part, indicate polar bonds with dipole arrows. C is to calculate the formal charge. And so let's, I'm going to do that here. To calculate the formal charge, use count, well, a formal charge is for each atom. You have to calculate a formal charge for each atom. So for water, see, we're going to calculate a formal charge for the hydrogen, a formal charge for this hydrogen, and a formal charge for the oxygen. Okay? For HF, we're going to calculate a formal charge for the hydrogen and the fluorine. For oxygen, it's for this O and this O. For carbon monoxide, it's for this C and this O. So you will do a formal charge for each atom. How you calculate it is you take the electrons according to the periodic table. I'm running out of room, so I'm going to make up some abbreviations. You take the electrons from the periodic table. You subtract out the electrons in the Lewis structure. And that gives you your formal charge. Okay, let me show you what I mean by looking at this one, water. So I'm going to calculate the formal charge for hydrogen here, for oxygen here, and for hydrogen here. According to the periodic table, hydrogen should have 1 electron because it's in group 1. According to the periodic table, oxygen should have 6. And in the next element, hydrogen, according to the periodic table, it has 1. Now, you've got to watch how you do this next part, how you tally the electrons in the Lewis structure. Because y'all know in a bond, like in this bond right here, there's 2 electrons. When you're doing formal charge, you have to split them when you count them, okay? So there's 2 electrons in that bond. See, hydrogen's got 1 of them, and oxygen's got 1 of them. So when we say how many electrons does hydrogen have in the Lewis structure, you just count 1 of these. So hydrogen's formal charge is 0. Now oxygen, let's move there. When we're counting up oxygen's electrons in the Lewis structure, see, these belong only to oxygen. These dots belong only to oxygen. But 1 of these in each bond, oxygen gets. So how many is that total? The circles, I'm going to redo them so we can count them together. 2, 4, 5, 6. So oxygen has a 0 formal charge. I'm going to erase those little things I put on there. Hydrogen has 1, so it has a 0 formal charge. So that's how you would calculate the formal charge for each atom in water. And what you can do it like I did it, where you show the calculation, but if they're all 0, you can actually write, well, they're all 0. Formal charges are all 0. Okay? Now, you go through and do the formal charge for each atom on this page. This page of my screen, but you guys do it for finishing out page 1. Pause the video, do all the formal charges, and then I'll show you how. Okay? For hydrogen, it would be 1 minus 1 is 0. For fluorine, should have 7 on the periodic table. This fluorine has 2, 4, 6, 7. So 7 minus 7 is 0. Okay? For the next one, according to the periodic table, oxygen should have 6. This oxygen has 2, 4, 5, 6. The other oxygen also has 6, so it has a 0 formal charge. Carbon monoxide. According to the periodic table, carbon has how many? It has 4. How many does this carbon have? 2, 3, 4, 5. 4 minus 5. Carbon's formal charge is -1. For oxygen, according to the periodic table, oxygen should have 6. This oxygen has 2, 3, 4, 5. 6 minus 5 is +1. Okay, so formal charges are usually 0, guys. That's very common for everything to be 0, as y'all could see. And maybe on those first ones you were thinking, oh, it's going to be 0 every time. But it's not. Formal charges are small. You might get a -1, you might get a +1, you might get a -2, you might get a -3. -2 or +2. If you get a -3 formal charge, or +3, -4, +4, that's getting a little crazy. Let's keep it 0, 1, and 2, okay? It shouldn't get that huge. Also, look, carbon monoxide, for example, even though one of them has a formal charge of -1 and one is +1, we all know that balances out to be 0. The total of the formal charge should equal the charge on what you're dealing with. See, oxygen doesn't have a charge. It's 0. Carbon monoxide doesn't have a charge. It tallies to 0. HF doesn't have a charge. It tallies to 0. Okay, let's do a few more on the next page because we start to encounter something different here. The next page starts with the ammonium ion, and I trust that if I said ammonium ion, every one of y'all would know that this is what the ammonium ion looks like. Okay? We haven't done one with a charge yet, but we do know that when we do the formal charge, it ought to tally up to be +1. but something happens here when you have a charge. And it's in the electron tally. In ammonium, there's 1 nitrogen and 4 hydrogens. According to the periodic table, nitrogen has 5 electrons and hydrogen has 1. This gives us a total of 9. Guys, what charge does an electron have? Negative charge. Therefore, if we have a plus charge up here, and we do, we have to take an electron away, because removing electrons gives a negative charge. If this had been a +2 charge, we would have taken away 2 electrons. Likewise, if that had been a -2 charge, we would have added 2 electrons. But what that changes, see, is step 1 in your tally, we've got 8 electrons to draw for ammonium. And the next one's also going to be a slightly different compound because it's sodium sulfide. It's an ionic compound. And you'll remember an ionic compound is when the electrons have been transferred. So I'm going to go ahead and draw this one for you because I'm not real... we don't draw a lot of ionic compounds. Everything else on this sheet, these are all molecular. But in sodium sulfide, see, sodium has 1 valence electron. Right? But since this is ionic, it's actually transferred its electron to sulfur. So sodium doesn't have a charge anymore. And typically the way you draw something that has a charge is you would put square brackets around it and show that charge. And see, sulfur, even though it only has 6 electrons, what has happened here is this sodium gave one of its electrons to sulfur, and this sodium gave another electron to sulfur, which gave sulfur its octet, and also a -2 charge. And so this is the Lewis structure, if you will, for sodium sulfide. Okay, and on that one, guys, we're not going to answer anything else about sodium sulfide on that sheet until we get to the very bottom square. And we will not get to that square in this lecture. We will talk about that in the next lecture. But the rest of them, you're going to answer, okay? So here's what I want you to do. Starting with this page, ammonium ion, I want you to draw the Lewis structures for everything on that page and then finish it out, okay? There's 8 others because there's 4 pages. I want you to draw bond dipoles for all of them. Sorry. Thanks, Flash. He startled me. I want you to draw the bond dipoles for all of them, and I want you to calculate the formal charge. And then I'm trying to talk over the dog. Flash.
Flash, come here.
I think it's FedEx. He's not going to stop till FedEx leaves. Well, the dog is ending the lecture. So when we pick back up, I'll show you all. I'll go through them with answers, and then you guys can, we'll do a conference with questions or what have you.